Hello students, I will try in this video to technologically introduce the principal parameters that permit to define the drawing or the deep drawing process, of course as simply and as clearly as possible. Okay, let's go. First of all, it should be remembered that the principal features that can be carried out on a sheet metal blank are the shearing features and the forming features, and I talked about this in the previous video. And in this video, I will talk about the drawing features, mainly the cap draw and the box draw. And as its name suggests, the cap draw consists in applying a plastic deformation on a flat sheet metal blank in order to obtain 3D sheet metal parts in the shape of a cap, as it is depicted in this figure. And the box drawing will permit to obtain by plastic deformation a 3D sheet metal part in the shape of a box. Now, the principle of the deep drawing is depicted by this animated figure. And as you can see, we have the die and we have initially a flat blank and which will be held by the blank holder, and we have the punch which will apply the punching force in order to transform the initially flat blank into a 3D sheet metal part. Now it's to note that a drawn sheet metal part will be sized based on this model. And here D1 represents the characteristic dimension of the top portion, D represents the characteristic dimension of the bottom portion, small r represents the bottom curve radius, capital R represents the flange radius, and H represents the height of the drawn sheet metal part. And the characteristic dimension means the diameter if we have a cap draw, and it represents the distance between two parallel lines if we have a box draw. In the case of a cap draw, the diameter capital D of the initially flat blank is given by this formula based on the principal dimensions of the cap draw. It's to note also that there are some parameters associated to the deep drawing process. These parameters are defined based on this model, and the principal one are the clearance between the punch and the die, and this clearance should be greater by 10% than the thickness of the initially flat blank. There are also the drawing ratio between the diameter of the initially flat blank and the diameter of the punch. And during the deep drawing process, we define the reduction R, which is equal to the difference between the diameter of the initially flat blank and the diameter of the punch divided by the diameter of the punch. These parameters will permit to properly carry out and evaluate the deep drawing process. In fact, in order to ensure a proper deep drawing, the reduction R must be kept lower than 0.5 and the drawing ratio must be kept lower than 2. If this drawing ratio is higher than 2, we must apply a redrawing, which means that the deep drawing process must be carried out through a series of dies, as it is depicted by this figure, in such a way that the considered drawing ratio upper limit is respected. That's all for this video. I will appreciate all your questions, your remarks, and your suggestions in the comments. Thank you very much for your attention.